So 5.5b is about the rational zero theorem. The rational zero theorem says that if we have a polynomial, every rational zero has to be related to our constant and our lead term. We get the p's by taking a factor of our constant, or our a sub 0. We get the q's by finding any factor that divides evenly into our lead term coefficient. So every rational zero we're going to find. So what's a rational number? A rational number is any number that can be written as a over b when a and b are integers. So 2/3 is a rational number. 1 is a rational number. 5 is a rational number. -5 is a rational number. So all rational zeros are dependent upon your last value and your first value. Okay, so you have to keep that in mind when you do these. Okay, so make sure you have switched that is a sub n and that is a sub 0. So the p's come from here and the q's come from there. So let's look at an example so we can put this into practice. So up to this point, we have been given the zeros, but the rational zero theorem, if we take these 3 steps, then that's how you're going to find multiple zeros. So let me just go down the list. You already have this written out, but let me just go down each step so that so you understand the way to work this. So if it says that we want to find the zeros, but they didn't give you any, the first thing you want to do is list all the possible p's and q's. Then you're going to plug those into the function until you find a 0. Once you find one when you plug in that gives you 0, we're going to factor that out. So if we plug in 1 and we get 0, we are going to factor out x minus 1. If we get -2 is a 0, we're going to factor out x plus 2. So this just allows us to quickly find possibilities that might work. Now, if something is on the list, that doesn't mean it has to work. It means it might work. So what this does is this allows us to narrow down the possibilities of things that work. Now, these are polynomials that you can enter into Desmos if you're having a difficulty finding the first 0, because all you need is the first one. If you can find the first one, then you can proceed and things will go nicer. Okay, so Desmos can be helpful as you go through this process. So let's take a look at an example. It says, use the rational zeros theorem to list all possible rational zeros of the following. So the p is any number that divides into 7 evenly. So the only numbers that divide into 7 evenly are 7 and 1. The q is related to your front coefficient. Our q is anything that divides into 4 evenly. So 4, 2, and 1. Now the list we are talking about is the list of the p's over q's. So now let's combine all the p's and q's. So I start out with p, and I stick with the number 7, and I divide it by all the q's. So 7 divided by 4, put your plus or minus. 7 divided by 2, put your plus or minus. 7 divided by 1, plus or minus. Now, those fractions should be reduced as much as possible. Don't try to go with mixed numbers. I just want the p over q. The next number on our list is 1. So now we're going to divide 1 by all of the q's. So the first one would be 1/4, plus or minus 1/4, plus or minus 1/2, and plus or minus 1. Now, I said to reduce, and I didn't. 7 over 1 should be reduced to 7. Now, you don't have to write this next part, but unless you want to. But in ALEKS, they want 7/4, comma, negative 7/4, comma, 7/2, negative 7/2. They want that whole list broken apart. I do not believe there is a plus or minus symbol. So just keep that in mind. I don't think they want a plus or minus symbol. Check, I mean, because that's going to shorten how many you have to write. But the list includes all positive and negative versions. Because if you divide by a positive, you get a positive. You could have divided by a negative and got a negative, you know. So I always just kind of keep the plus or minus there as I just write it every time. Okay. So if Alex just lists, hey, what's all possible zeros? If it has the word all possible, you just make that P over Q list, you're done. So you don't have to really do any math past that. So that's what question 10 is looking for. Now, question 11, look what it says. Look how it's worded differently. It says, the function below has at least one rational zero. Use that fact to find all of the zeros for the function. And if there's more than one zero, separate them with commas. We want exact values, so if there's any square roots, you're going to write them. If there's any fractions, keep it in fraction form. Okay. So first, let's do our P over Q list. Our P is 7 and 1. Our Q is 6, 3, 2, and 1. Now, I am going to build the P over Q's. First, I'm going to divide 7 by all of my Q's, leaving them in fraction form. 7/6, 7/3, 7/2. 7 divided by 1 is just 7. Now I'm going to divide the 1 from my P list by all of the Q's. So that's 1/6, 1/3, 1/2, and 1. Okay, so now I have that entire list to choose from. They have told me that at least one of them is on that list. One of the zeros is on that list. Now you could put this into Desmos to find one, but you're not going to be able to use Desmos on the test. So let's figure out, if you're really stuck on your homework, go to Desmos. But for me, let's find the algebra. So here's my h of x function. Okay, now what I'm going to do is I almost always start with 1 and -1. So, because many times these will have a 1 or a -1 that works as a 0. Now we're just looking for plugging in 1 and getting 0. Well, that's going to be 6 plus 37 minus 34 plus 7. Now that answer is going to be 16. So 1 is off of my list. So positive 1 doesn't work. So 1 is not a 0. So x minus 1 does not divide in evenly. It would have a remainder of 16. So then I'm going to try -1. We can stop the instant we find a 0. So the instant you try something that it works and gives you 0, we're going to stop. So we don't have to try everything. If you're unlucky and you keep picking in the wrong things, then you might have to try the whole list. Okay, but anyway, if we plug in -1, we get -6 plus 37 plus 34 plus 7, which is 62. No, that's off the list. So just because I've tried quite a few so that we don't have to write it down again and again and again and again, let's try 1/2. That is one of them, yes. Okay, so if we plug in 1/2, we get 6/8, which is 3/4. We get 37 divided by 4, which is just 37 over 4. And then we get 34 divided by 2, and 34 divided by 2 is 17. And then plus 7. Guess what? We found one. Now, as soon as we found one, then, if 1 didn't work, you could try -1. If that doesn't work, you could try 2 and -2. You don't have to use fractions, but I just knew 1/2 worked. So that means that x minus 1/2 is the factor. But our factors will not have fractions with them, so we have to put the denominator by the x. Or you can think of multiplying through by 2. So that's the factor that divides evenly. Now, that is not eligible for us to use synthetic division because of the fact that there's a 2 on the x. I just
put 1/2 and then multiply by 1/2 every time for synthetic division.
It won't work completely right. Your answer will be off by a factor of 2. So it just is safer when you get a fractional answer to put the denominator on your x and divide out that. So we're going to divide 2x minus 1 should evenly go into 6x cubed plus 37x squared minus 34x plus 7. Though, if you're taking a quiz on this stuff, you might only have 2 questions. You know what I mean? 3 questions because of time. Yeah. And some of the time, I may even actually say, hey, I know one of the zeros is 3. Use that. So usually I'll give you 1 question like that and then 1 question where you have to try the possibilities. Okay, so let's do the division. What times 2x is 6x cubed? That would be 3x squared, so put it above the x squared. Now remember, we're going to distribute. We get 6x cubed minus 3x squared. We're subtracting, so change the signs of both. The first term should always go away. We're left with a 40x squared minus 34x because we need to bring down the next thing. We had 2 terms, we need 2 terms. Now we're going to do it again. What times 2x would give me 40x squared? That would be 20x. Now we are distributing, so we have to multiply that by both things. We get 40x squared minus 20x. We are subtracting, so we're going to change the signs of both. First term should always get eliminated. Negative 34 plus 20 is negative 14x. Bring down the next thing. We are guaranteed we should be getting a 0 denominator because that's what should work. And if you don't, check over your work. Okay, so now what times 2x would give me negative 14x would be negative 7. We're distributing. We get negative 14x plus 7, but we are subtracting. So change the signs of both and add up. And we do indeed get a 0 remainder. That's what we're looking for. Okay. So what we have just learned is that h of x is 2x minus 1 times 3x squared plus 20x minus 7. That's what we have just learned. Now, if all this is right with the world, that quadratic is a factorable quadratic. If it's not factorable, to get the exact zeros, just use the quadratic formula. And if you aren't good at factoring and you want to use the quadratic formula, that is always a method to find the zeros. That's why that formula was created, to find the zeros of a quadratic. So if you want the zeros of this, you either have to factor it or use the quadratic formula. Okay, this is a factorable quantity, which makes our life much nicer. It's going to be 3x and x, positive 7 and negative 1. Now, if you forget how that works, you can try slide and divide. but 3x times x is 3x squared. This is a positive 21 minus 1, which is the 20 in the middle. And then negative 1 and 7 make the negative 7 in the back. Okay. Now, if they said, what is the linear factorization of this polynomial? That's your answer. I have factored it into x, x, x. There were x cubes, and I show all of the x's. So that is the linear factorization. But that is not what they asked for. They said, what are the zeros? So remember how you did it on that quiz we took recently. The zeros are just where does each parenthesis, each factor equal 0. So that's a pretty easy thing to do now. That's why we factored in the first place, because finding the zeros becomes a pretty darn easy thing. And I don't think I need to spend any time showing you how to solve that. I hope that you know that that's 1/2, that's 1/3, and that's negative 7. If you were to graph this function into Desmos, it would hit the x-axis at positive 1/2, positive 1/3, negative 7. Now they always show the the decimal equivalents. So like they would show 0.5, 0.333, and negative 7. Alex, that won't work. They want exact values. So you can't put 0.333. You have to have 1/3. So that's why that factorization can be so important. Now, if you recognize that 0.333 is 1/3, go for it. But that's what they want. They want the zeros separated by commas with exact values, no decimals. So you would put into Alex 1/2 comma, 1/3 comma, negative 7. Okay. Any questions about that problem? There's a lot of stuff in every problem. And you'll notice it's kind of a combination of things we've already been doing. It's just more. And that's really what you'll see in this class throughout the year. There's just a little bit more added every time. Okay, let's do another one. It says find the zeros. Factored form are what we want. So I notice that there's no way right now to factor it. A cubic usually can be factored using grouping, and it has to have 4 things, and it doesn't have 4 things, and there's nothing I can see that I can take out. So I have to try another way, and that's where we use the p's over q's. So my p's are plus or minus 1. It's only a 1 in the back, so it's only plus or minus 1. Our q's have more to them because it's any number that divides into 4. So that's plus or minus 4, 2, and 1. And if we combine them, the p's over q's we can check are 1 plus or minus 1, 1/4, and 1/2. So I always tend to try plugging in 1 or negative 1. If 1 doesn't work, I jump to negative 1. Just because, ones are easy to plug in. So I would always just shoot for a 1. And so the first thing I'm going to do is plug in 1. Well, 1 gives us 4 minus 3 minus 1, which, guess what, is 0. First step. Bam, that's great. Now, what that tells me is, because remember, if the 0 is a certain number, the factor is always x minus that 0. So the factor for this one, the associated factor, is x minus 1. Now, x minus 1 is a factor that can be divided out using synthetic or long division. So if I have the option to use synthetic, I just think it's a little easier. So I'm going to put 1 in the corner. I'm going to use my coefficients of 4. Now there isn't an x squared, so you have to put a 0, negative 3, negative 1. So those are my coefficients. And then let's build our box. So I've just built the box so it's ready to go. So remember what we do. We multiply. 1 times 4 is 4. Write it down. Add them up. Multiply. 1 times 4 is 4. Write it down. Add them up. That's wrong. That's positive. Multiply. Write it down. Add them up. Guess what we got? 0 remainder. We should. Or this was wrong. They should always coincide. Okay. So what do we know? Well, we know that f of x is x minus 1, the thing we took out, times the associated quadratic right here. Now remember, that was cubed, so this first term here has to start 1 power lower, so that's x squared. So that's going to be 4x squared plus 4x plus 1. Now, if all is right with the world, we can factor that. If we can't factor it, you have a quadratic formula that finds zeros. So that would be 2x plus 1 times 2x plus 1. It does factor. Now, do you remember when we were learning about zeros and bounces? Since 2x plus 1 is a repeat with any multiplicity that is even, this one would go through the x-axis, and this one is a bounce at the x-axis. So my zeros are where x minus 1 equals 0 and where 2x plus 1 equals 0. We already found the 1. We already did any math associated with that. Remember that 0 was 1. We plugged in 1, we got 0.
How did it factor to 2x plus 1?
4x squared is 2x times 2x. And then 1 is 1 times 1. And then if you do the foiling, this is 2x plus 2x, which is the 4x in the middle. Now you can use slide and divide. Take the 4, slide it over. It's x squared plus 4x plus 4, which is 2 and 2. And then it will also work out if you use that technique. Okay. And so that last one gives me a 0 at negative 1/2. So if Alex asked what the zeros are, just list 1 and negative 1/2. I don't think they would want you to write out negative 1/2 twice because it's a multiplicity there. It's not like an extra 0. But watch the wording, how Alex asks you when you're doing it, okay? Does anybody have any questions about example 5? It's a lot of stuff, for sure, okay? Okay, so the homework, we're only going to be doing the evens for now because you saw how long these problems can be. So for each one of these, this is your f of x. It says it's equal to 0, so that is just a way for them to say to find all the zeros. The zeros will make that equation true. So you can write 22 as f of x equals x cubed minus 3x squared minus 10x plus 24. And then you can start plugging things in that go into 24. Always start with 1, negative 1. Then go 2, negative 2. And then just keep, you can try for that one, 3, negative 3, 4, negative 4, 6, negative 6. There's lots of things to try. So you're only doing the evens for those. So you have a quite amount of time right now. So try some of them now, okay? There you go.